can you do with this ball? You can push this ball. You can push this ball, applying some velocity, say velocity 10 meters per second. If you push it, applying 10 meters per second, the ball will eventually hit the ground. So initial velocity is 10 meters per second. And this is, let's say this is 20 meters tall. I wanted to find a lot of things. I wanted to find x, y. I wanted to find acceleration at x direction and acceleration at y direction. I wanted to find a velocity, initial velocity at x direction and initial velocity at y direction. I wanted to find velocity final at x direction, velocity final at y direction. I wanted to find displacement at x direction and displacement at y direction. Finally, I wanted to find t. There is no direction for t because t is a scalar quantity. We're just gonna write t. I wanted to find velocity final, and I finally want you to find the value of the theta. So we are finding a lot of things in the whole the whole table. We have to fill it out. So we have y initial is 0 and this y final is 20 meters, negative 20 meters. We have velocity. There are two components of the velocity. Velocity initial x is 0. Velocity initial x, we have two components of the velocity. Velocity initial x is 10 meters per second. Velocity initial y is 0. Over here, we have when ball hit the ground, when something hit the ground, we should see 3L. Vx, Vy, and the V. We should see 3 arrows. So this is Vx, this is Vy, and this is of course V. And finally we're going to find the theta. Let's find it. Acceleration at x direction always is 0. Always is 0, no exception. Acceleration at x direction always is 0. Acceleration at y direction is always negative 9.8 meters per second square. Velocity initial x. Velocity initial at x direction is 10 meters per second. Velocity initial at y direction is 0 meters per second. velocity final at x direction. As I said, velocity at x direction is always remain same because acceleration at x direction 0. So velocity final at x direction is also 10. Why velocity final? Why the velocity final at x direction is 10? Is because acceleration at x direction is 10. So velocity does not have to fight with acceleration because at x direction there is no acceleration. Acceleration only at y direction. That means the velocity at the x direction. Velocity at the x direction is same, is 0 everywhere. Velocity at the x direction, velocity vector at x direction remains same, entire trip from beginning to the end. So velocity at x direction is 10, velocity at x direction 10, velocity at x direction same throughout the trip. Velocity final at y direction, let's find that. So velocity final at y direction is, so velocity final, one of the kinematic equation is velocity final is velocity initial plus at. We are interested at y direction, so we're going to write y. So this guy goes to 0 because velocity initial at y direction is 0. So velocity final at y direction is negative 9.8, and t, we do not have, I have t, so let's find t. How can we find t? It's very easy. So we're going to write y is equal to y naught plus v I y t plus half a y t squared. v I y is 0, y initial is 0, y is negative 20, half negative 9.8 t squared. Negative 20 is equal to negative 4.9 t squared. So t is equal to square root of 20 over 4.9. So t is equal to 2.02 seconds. So now we're going to plug that t over here. So t is equal to, we're going to write 2.02 seconds. We're going to plug that t over here, 2.02 seconds. Now v final y is negative 19.8 meter per second. So you're going to go over here, we're going to write negative 19.8 meter per second. Now we're going to find the x. Finding x is very easy. You're going to use the same formula but the x component. So x is x initial plus a v I x t plus half a x t squared. This guy is 0. This guy is 0 because acceleration at x direction is at 0. And x initial, y initial and x initial both 0 right here. So x is VIX is 10 and t is 2.02. So x is 20.2 meters. So from here to here, the range ball landed 20 meters away from is the original place. So 20.2. What is the delta y? Delta y is this one, negative 20. Negative 20 meters. What is the v final? Now we're going to find the v final. How can we find v final? That's very easy. We have space over here, so you're going to find v final. We have one arrow, we have two arrows, we have three arrows. So you're going to do vector addition. Arrow number 1, we're going to put our arrow number 1. We call it arrow number 1. The name is Vx and magnitude is 10. We're gonna write our arrow number 2. Vy and magnitude is 19.8 negative. We're gonna do head and tail method. So this is our head, this is our tail. We're gonna put, this is our head, this is our tail. This is 10 and this is 19.8. Of course negative. Now we're gonna find the resultant vector. Resultant vector is the final velocity. It's this guy. We're gonna call it v, velocity. How can we find the v? By Pythagorean theorem. V is vx square plus vy square. This guy is, as you remember, 10, and this guy is negative 19.8. So V is 22 meter per second. So the magnitude of this arrow is 22 meters per second. We are not done yet. We have to find the angle. How can we find the angle? We're going to use the SOHCAHTOA. We're going to use the tangent theta. So now the SOHCAHTOA gives us tangent theta gives us, if this is theta, opposite is 19.8, opposite is 19.8, and Jason is 10. So theta must be tangent inverse 19.8 over 10. So theta is 63 degrees. So you're going to come back, we're going to say that when ball hit the ground, the ball, when you push the ball with 10 meters per second, the ball hit the ground with 22 meters per second of velocity at 63 degree angle. When you push the ball with 10 meters per second, the ball hit the ground with 22 meters per second velocity at 63 angle.